Welcome to Solving Systems of Equations by Elimination, and solving systems of equations using all three methods: graphing, substitution, and elimination. Take notes while I'm teaching, pause as often as you need to get your notes down, and every time we arrive at a you try, pause, attempt the problems, and then press play when you're ready to see the solution along with my work. These are the topics we'll be covering in this section. Let's begin with a quick reminder of what a system of equations is. In this section, we'll be covering two linear equations. A solution to a linear equation is any ordered pair such that that ordered pair is true for both equations when you plug them in. Let's move on to elimination. The goal for elimination is to add the equations together to eliminate one of the variables. How do we do that? We're going to multiply the equations so that one variable has the same number or same coefficient, but the opposite sign. Remember, to eliminate something, we need one to be positive and the other to be negative. So what can happen? Sometimes you can just add to eliminate right away. Sometimes you need to multiply one equation by -1. Sometimes you need to multiply one equation by a number, and sometimes you have to multiply both equations. We're going to do a few examples of each kind. The directions say solve the system. Now I'm not going to graph, neither of these are y equals mx plus b. I'm not going to use substitution as neither of these are x equals or y equals. So I'm going to see if I can eliminate. Is there a coefficient that's the same number but opposite signs? And you can see that these x's here have the same number too, but opposite sign. So I'm going to just add to eliminate. So 2 plus -2 goes to 0. And then 3 plus 5 gives me 8y. And 11 plus 13 gives me 24. I'm going to divide both sides by 8. Y is equal to 3. I'm halfway done. We have y, we need to find x. It doesn't matter which equation you plug into. I'll just plug it into the top here. So we get 2x plus 3, instead of y, we'll put 3, is equal to 11, and we'll solve. So 2x plus 9 is equal to 11. We're going to subtract 9 on both sides. We get 2x is equal to 2. Divide both sides by 2, x is equal to 1. The ordered pair is 1, 3. You can check it in both equations, or the one you didn't try, -2, 1 plus 5 times 3. Type it into your calculator. Do you get 13? That's your solution. We'll do one more like that. So no graphing, no substitution. I can see if I can eliminate. I'm going to put a 1 on that. So these x coefficients do not match, but y's do, and they are opposite sign. So we will add to eliminate. 1x minus 2x is -1x. 2 minus 2 is 0, and 2 plus 0 is 2. Divide both sides by -1. X is equal to -2. We're halfway done. We're going to plug that in. You can plug it into the top or the bottom. It doesn't matter. So we've got 1x, or 1 times -2, or you could have simply just plugged in -2. Plus 2y is equal to 2. So we've got -2 plus 2y is equal to 2. Lots of 2's. Add 2 to both sides. We get 2y is equal to 4. Divide both sides by 2. Y is equal to 2. It's the ordered pair -2, 2. You can check it in that other equation. -2 times -2 minus 2 times 2. Do we get 0? Nice. Okay, let's take a look here. You see the word notice in really big letters. So what are we looking for? All right, let's just see if we can do the same thing. So 7 and 8, those don't match. 5 and 5. Well, what happens if I was to just add to eliminate? 7 plus 8 gives me 15x. 5 plus 5 gives me 10y. Did these eliminate? No. The reason why is they were both positive 5x. So sometimes that happens. When that happens, we can simply multiply that top equation by -1 to change that sign. So we'll give that a try here. It's the same equation. We want this plus and plus to be different, one of them. So we'll multiply the top equation by -1. Be super careful here. You're going to multiply it by each term, even over the equal sign. So that's going to give us -7x minus 5y. I'm just going to get rid of that little guy there. Is equal to is equal to, and so we're multiplying it by this negative 26, that's going to give us positive 26. So 8x minus 7x gives us 1x, 5 minus 5 eliminates, and here we're left with negative 24 plus 26 gives us 2, x is equal to 2. So we've got x, we need to find y. I'm going to plug that back into that original first equation. 7 times 2 plus 5y, does it equal negative 26? So we get 14 plus 5y is equal to negative 26. I'm going to subtract 14 on both sides. We get 5y is equal to, type that into your calculator, you'll get negative 40, divide both sides by 5, y is equal to negative 8. So x is 2, y is negative 8. Let's just check it in that other equation. 8 times 2 plus 5 times negative 8, do we get negative 24? So type that in, 8 times 2 plus 5 times negative 8, and it does in fact work. Let's do another one. So we're going to eliminate here, and we notice right away that these 2's match, but they're both positive. We want the top to be negative, so we're going to multiply the whole equation by negative 1. I'm going to put a 1 there. So we're going to distribute the negative 1 to the entire thing. Don't forget about that 6. So that's going to give us negative 2x, negative 1y, and negative 6. 2 minus 2 eliminates. We get 1y is equal to negative 2, y is equal to negative 2. So we found y first. We need to find x next, so we'll plug that y in. So that's 2x plus 1 times negative 2 is equal to 6, or 2x minus 2 is equal to 6. We'll add 2 on both sides. 2x is equal to 8. Divide both sides by 2. X is equal to 4. Now, a common mistake would be to write them in the order that you got them, but this is not our x and this is not our y. So you want to be really careful. Sometimes we find our y first, which means it's going to be 4, negative 2. All right, you try the following 3 problems on your own. Press play when you're ready to see the answers and the solutions. And check your solutions here. Maybe you dropped a negative along the way. To check my work along with your work, and then we'll move on. So we've got 2 different equations here. So take a moment to notice, maybe pause and investigate the x and the y on either side. And this system here, we can just add to eliminate. We have the 7 and the opposite signs, but here 3 and 4 don't match and 7 and 14 don't match. So take a moment, pause the video again, and predict maybe what we could do to make a number match. Great. And so if you thought, oh, well, 7 can go into 14, if I could just multiply this top equation by 2, then I would get that negative 14y, and that would be exactly right. So that's exactly what we're going to do next. So when we notice that there are no matching coefficients, negative 5 and 2, negative 2 and negative 12, we see, okay, is there any way that I can make a 5 go into a 2 or a 2 go into a 12? And it's right there, that 2 and 12. Now, I could multiply 2 by 6. Now let's notice what kind of a 2 is that? It's a negative and a negative. See how those symbols match? We want to make them different. When we want to make them different, we multiply by a negative. So we're going to multiply the top equation, oops, skip that 5x, by negative 6. So on the bottom we get 30, positive 30x. Now negative times a negative is a positive 12y. There you go. You get that opposite sign, same number. And then negative 25 times negative 6 is going to give us a positive 150. Now I know what you're thinking. These numbers are really big. We're just going to keep going. So we get 32x. These eliminate are equal to 160. We're going to divide both sides by 32. And we get x is equal to 5. That seems more reasonable. We're halfway done. We've got our x. We need to find our y. I like to plug it into that first equation, but it really doesn't matter where you plug it in. Negative 5 times 5 minus 2y is equal to negative 25. And keep going. We get negative 25 minus 2y is equal to negative 25. We're going to add 25 to both sides. People start to panic here. Negative 2y is equal to 0. It's totally fine to get a 0. Divide both sides by negative 2. 0 divided by negative 2, we get 0. But if you're really worried, we're going to take a moment and check it with that second equation. So 2 times x minus 12 times 0, does that give us 10? And it does. We'll do one more like that. Solving the system. So this is that first example that we talked about earlier. So maybe you want to pause and think about, okay, can I get a 3 into a 4, a 7 into a 14? And yes, we can get that 7 into 14 by multiplying by 2. Let's just decide if we need to change the symbol. We have a negative and a positive, so we are all set. So we're going to multiply the whole top equation by positive 2. We'll get 6x minus 14y is equal to 28. 4x and 6x, 10x is equal to 0. No panicking. 0 is a perfectly fine number. X is equal to 0. We've got halfway there. I'd like to plug into that top equation. We get 3 times 0 minus 7y is equal to 14. Well, that goes away. We get negative 7y is equal to 14. Divide both sides by negative 7. Y is equal to negative 2. So that's 0, negative 2. Let's just check it. 4 times 0 plus 14 times negative 2. Does that equal negative 28? Type it into your calculator to see. And it does. All right, we've got another. That concludes part 1. Continue on to part 2.